and worked with. Now, I'm very pleased that here at the innovation stage we have different highlights, theme highlights that are very important for the industry, manufacturers, the exhibitors here at EMO. These are subjects, themes, which are discussed on a daily basis, but maybe are not taken into consideration enough. And this is what we'd like to do at the innovation stage. And that's what it's about in our first session. This will be about the interaction between slideway oil and cooling lubricant. And we will learn why both are only perfect partners when they separate cleanly and how this increases precision, service life, and productivity. This is exactly what we'll be talking about here now at the innovation stage. Please welcome with me, with a big hand, Thomas Bergmann. He's Senior Lubrication Field Engineer at Esso Deutschland GmbH. And his presentation is entitled Perfect Partners, but Better to Be Separate, the interaction between slideway oil and cooling lubricant. And as always, you can ask your questions via Slido. I will talk to him afterward, but let's bring him up on stage first. Let's give him a big hand. The floor is yours. Thomas, go ahead. Good morning. Hello to everyone. It's nice to have all of you here for the first presentation this morning. My name is Thomas Bergmann. I am an application engineer at ExxonMobil, and I am a mechanical engineer by training. Today I'm going to talk to you about the magic of chemistry. The title here is Perfect Partners, Even in Separation. So I'll start with a question for you. Maybe you could raise your hand. Who here works in machining, who has direct contact with slideway oils, hydraulic oils, cooling lubricants? You do. Okay, great. You too. Great. So you've selected the right stage today. I'd like to do a little bit of a thought experiment with you. Imagine this, you've got a machine tool, you work in machining and everything's working perfectly. The machine is running perfectly, it doesn't stutter, it doesn't vibrate, the tools last, your people, your employees are healthy, it doesn't smell, great durations, work piece, or rather tool duration. Is that reality? You all actually said it wasn't, so unfortunately that isn't reality, and therefore I'd like to give you an overview of, how should I put it, tell you about a few tests, possibilities of how slideway oils and water-immiscible cooling lubricants can be tested, assessed, evaluated for your productivity and for your quality in production. And for this, we've got two different tests that I'll talk about, each separately. This is the demulsibility test. We want to achieve quick separation of the slideway oil from the cooling lubricant. So we can skim one off, take the medium out of the cooling lubricant, and you can get the best possible performance for your cooling lubricant. Now let me tell you about the terminology first. We've got emulsibility and demulsibility. Let me give you an example here. Emulsify, that's when you've got two different substances that actually don't want to mix, and you bring them together with a substance in between. Now, I like cooking at home, and I like to keep things kind of graphic. So, let's say in the evening you're going to make a salad with tomatoes and mozzarella, and you use oil and balsamic vinegar, and then you of course have to spread that evenly. And these two substances like to stay separate. They have no affinity. You can stir it as much as you want. They will always stay separate, and for that we need an emulsifier. And in this case, it can be mustard. It's a great emulsifier. You put that in, you mix it up, and then you have these two substances, and these two substances link together. It's not a solution. there are fine particles, but they're evenly distributed. Now, we don't want to emulsify, we want to demulsify. So we need a substance which breaks up this connection. Now I have a comparison, it's not chemically correct, but I'm a mechanical engineer, so I can allow myself to do this. Let's take milk. Milk is an emulsion of water and fat. It looks homogeneous. And because of its chemical composition and the way it looks, it does look like one substance. Now, if you want to split that milk up, then you take, for example, vinegar, like for producing cheese. And vinegar, for example, would break the milk down into fat and water. That's a kind of a graphic example to show you that we need some sort of formulation for this. Now, as I said, we want to make it possible for you to use simple means to test, tests to evaluate which substances can give you the right performance and what the benefit is. Now here you've got a machine, it's an emulsifier, and for that you put an emulsion into here, and there's the mixing ratio, 60 milliliters, 20 milliliters, so 25%. And then above there you put in the slideway oil and you simulate leakage of slideway oil into the cooling lubricant. Now, all of this is done at room temperature, ambient temperature. It's swirled around 1500 RPMs for 5 minutes, and then you let it settle. And then every few minutes, certain time gaps, you check how much of the oil is separated from the lubricant. Now you've got some different emulsifier technologies that we've got: boron acid, phenoxyethanol, propanol, and DCHA. And the leakage is simulated with 2 competitor products and with our mobile Vectra oil and our next generation product, mobile slideway oil, and I will try to pique your interest for that at the end of my presentation. This company, Mabinol, that is our partner, HBO Luptec. We are together at the fair with them today. That's the brand, Mabinol, from the company called HBU. And it's a very fruitful collaborative effort because, as I described at the beginning, both of these products have to be adapted to one another, and we have very close technical cooperation so we can achieve the best for you and your customers. And how does this look then after it's all mixed up? This is what the sample would look like. And now I have a question for you. Please raise your hand, or just nod or shake your head no. What demulsibility would you think is good, positive, after 60 minutes? What level of demulsibility? And there's a test. The test goes for 24 hours. My experience, my recommendation is just do the 60 minutes because you want to have quick separation. In real life, you don't have 24 hours time before you start skimming the substances. You have an idea? Number 1? Yes, great. I hope you can see it. I can see it. You see here, if you look at the percentages, 80 milliliters, that's the total amount, and almost everything is completely demulsified. You don't have an intermediate phase, you have a clear emulsion phase and a clear slideway oil phase. An example of how it might look is this. You've got an emulsion, almost no separation. And what this means is this. For instance, you wouldn't have any cutting performance on your machine tool. Your cooling lubricant would have air in it, and then you would have bacteria in there, so it wouldn't last long, your emulsion. Just a couple of examples there. Now, I've brought along a couple of charts on this for you. What you see nicely here is how quickly different slideway oils can be separated with different technologies. For instance, here, you have old technology that's used. You can get relatively good results there. Quick and complete separation or demulsification. That's boron acid, but with phenoxyethanol or propanol, the situation is different. So the products from Mobil, and we have brand name competitors that we also use. Mobil begins very quickly with demulsification, and it completely demulsifies. And you can see that other products here, if you use the emulsifier technology for the cooling lubricant, well, they begin demulsifying a lot later, and they don't completely demulsify or separate things. And this becomes even more obvious if you look at the new emulsifier technologies, DCHA. Now what you notice here right away is that there's one product, one slideway oil, and in this case, well, it emulsifies or doesn't demulsify at all, and the phase is all just one single phase. And this is exactly what I'd like to convey to you here. It's the first simple test you can use to assess the performance that you can expect in the machine. What are the advantages that you have if you want to have, well, if you get good separation, well, you can skim things off. You have a very clean working area. You have longer coolant life, less downtime, and it's, of course, easier for you to measure. Because if you've ever looked at a refractometer and measured the concentration in the machine, you have leakage oil that doesn't separate, that's always in there. You don't see a clear horizon or line. You can't very clearly distinguish between the two phases. And if you keep on going toward Industry 4.0, AI, or measurement systems, well, you would get incorrect results, and you don't even know what's going on in your machine. And I'd like to explicitly look at the first point there. That is your clean working area. Now, it sounds trivial, but you know what often happens in industry? If you don't have a clean working area, and the cooling lubricant isn't cleaned away appropriately, has anyone ever seen how you might have an operator working there take a spray bottle and a rag, and then they try to clean off the separation, the window there between them? Well, what did they do when they do that kind of thing? They reach in and clean it off like that. They put another surfactant in there, another emulsifier in there. So actually all of the chemistry in this ecosystem, and I call it chemistry in the ecosystem because all of these things have to perform together, and he just mixes everything up. Then you get foam, you get deposits, and then they use anti-foam substances, and then basically you've ruined the whole system. And then you have maintenance, and you have cleaning and additional costs that are generated. And I'd like to explicitly talk about one point here. That's the balanced formulation. That is the key approach for ExxonMobil, for all formulations. ExxonMobil and HBO Lubtech with their products. Well, we have a special approach, and that is a formulation that is based on the application. In other words, we look at the application, and then we formulate our products exactly on the basis of that application, not just in machine shops, everywhere, for turbines, for food, energy, the energy sector, woodworking, paper, basically everywhere. And when we talk about balanced formulation, I talk about often two different additives. First of all, the anti-wear additive and the corrosion protection additive, because both additives want to come to the surface of, or want to deposit on the surface of the metal. And maybe I can tell you about my two kids for a moment. Let's say you put a bowl of gummy bears on a table and you have two kids, just one bowl and two kids. See what happens. And it's like that with the additives, because both of them focus on being dominant and depositing themselves on the surface, which means that if you don't have a perfectly balanced formula with perfect chemistry in your products, either you're going to have great corrosion protection, but then you'll have wear, or you'll have great wear protection, no wear at all in your application, but you're going to have to expect corrosion. That's more or less the challenge that chemists have at our company when they're developing these products. And as you have seen, Mobile is very good in this. Mobile Vectra, that's been around for decades. I think the product itself is older than I am, and it still shows performance at an extremely high level. Then there's a second aspect that I'd like to tell you about too, that I'd like to point out. That's stick slip. And this always occurs if you've got different movements and you have first static friction and then dynamic friction. And this point between here, the machine gets the command to move, and when then the actual moment, when it actually moves, that's the critical moment. Or if you have high loads, big machines, and slow movement. And the products have to be designed and formulated for that. And if you don't have products that are designed and formulated for that, this is what you'll get. You will have imprecise production, you'll have higher wear, and you see it in the vibrations, in the surface markings, especially if you have to have a perfect surface, for instance, car, aluminum or alloy car wheels, you don't have any grinding, you always have machining, and if you have a marking on there, you've basically just produced scrap, and that's not what you want. And our products are designed for this. Our slideway oils are there to prevent, or designed to prevent stick slip. And I'd also like to tell you about some personal experience I've had. When I started, I said, well, I'm a mechanical engineer, and people will say, okay, what is a mechanical engineer doing working for a petrochemical company? Now, it was an honor for me, I can say, to once help set up a production facility from scratch. I started at on a greenfield site, and we finished with the ready-made production. And I get goosebumps when I think about this, because it was a very demanding project. And we went on through to volume production. We had the first products running with our materials, our processes, everything was great. We were satisfied. And industrialization then goes on. We duplicate machines, and ultimately we want to produce more and more. And I can remember one day then in the fall, it was a Wednesday, I had the tools that I shrank. I sent the materials to the machine manufacturer for pre-approval of the machine. I think it was about maybe more than 5,000 euros for the pre-approval. Everything was the same parts, same program, same tools, everything was identical. And then Friday morning, the machine manufacturer calls me and says, Mr. Bergmann, we ruined all of the milling tools. I said, what? He said, yeah, we don't have any milling tools. I said, that can't be. We've got this volume production process with the tools and everything. It's identical. And we then found out that the difference was the cooling lubricant together with the slideway oil. And this is a real example of what this can mean. And this is what prompted me to move to the petrochemicals industry, because I believe that we talk a lot about processes, about machines, about interconnectedness, connectivity, AI, but we talk much too little about the subject of lubricants, friction. And this is what I'd like to convey to you here today. I'm convinced that lubricant is not just some secondary material that you have to purchase. It is really a design element. It goes hand in hand with everything you produce, with all machines. The cooling lubricant can be crucial for victory or defeat. This is what I wanted to tell you about my experience. And last chart here is a bit of a teaser for you. I've brought along a chart with our new product for you. On the left-hand side, you have the well-known and often copied, never achieved mobile Vactra with approval for basically, well, many purposes around the world. And we want to maintain this lead, and thus we've come up with, I don't want to say a successor, but we developed a product and launched a product which even exceeds the performance of Vactra. And I'd like to invite you to come see us, and actually I'm open to a challenge. Test us, test our products together with our trade partners or directly with mobile. We can rise to that challenge. We'll accept it so that we can bring your production, your manufacturing facility up to a new level. Thank you for your attention. Let's give him a big hand. Thomas, thank you. I like to begin with feedback for the presentation, if I may. First of all, I'm really happy if we can make this a little relaxed here. And those comparisons were great. And I'm a layperson here, and you really brought me on board there. And this is great. We've got a couple of questions from the audience. I have a couple of my own, too. So let's begin here. Let's look to the future. And you might ask, okay, where are we going with slideway oils? Where are they heading? Will the oils that you presented here be used in other areas, for instance, for hydraulics, for transmissions? Well, I'll begin with that. Yes, you can do that. The slideway oils, when they're approved, they can be used as hydraulic oil or gearbox oil in machinery. No problem there. We're also working together. We're looking for partnerships with builders so that builders can say, yes, I can approve these and then put them into the market there. Now, it's not easy to find machine builders or other builders who want to deal with this subject. They just write a standard on it. And this brings us to the subject that I mentioned previously. A standard that was based on a working group with lots of different interests represented, but that doesn't mean that products that meet that standard are tailor-made for a certain application. And therefore, we at ExxonMobil have a very big department that establishes and maintains the contact with these companies. So I can say, yes, it is possible, but we actually want and need the cooperation so that we can move forward with this development. Well, that's well put. Something that I notice. The products are always moving forward and evolving, and you do that too. You might think it's a standard thing that you need in a standard machine, but nevertheless, you've always got to have innovation because everything else is developing and evolving too. Yes, and legally too. Let's look at REACH. You have fewer and fewer chemicals available that you can use, and then you've got to be creative. You've got to say, okay, how can I get higher performance out of the products that I still have in my chemical workshop? Here's an interesting question. Grease in the slideway, wouldn't that be better than oil? Yes and no. It depends on the application. For grease, well, it might work, especially if you're looking at sealing. Grease there can also provide a certain level of sealing performance so that you don't have the leakage of the well, cooling lubricant, and grease also in terms of heat transfer. Well, it's not ideal, and then because if there's wear, everything remains in the grease, and you then have more wear. Oil has completely different properties that are positive in this context. So it really depends, and you've got to look at it one case at a time. There are applications where grease makes sense, yes, and we've got greases in our product line, the greases that are less viscous than Nivea cream even. That's in our product lineup. But basically, we really depend on input from the machine builders, what they need and which direction we should go in our developments. Very good. Okay, here's another question that we have to ask. You told about the advantages of where we're going and the significance of the developments. Now, you talked about service life. Now, in developing your products, do you talk about savings? Please don't misunderstand me. When you begin developing a new product, you, Esso Mobile, really put a lot of effort into there. And then you want to have a good result. You say this will be an additional advantage for the user, for the machine builder. Could you say that when you use this new solution that we've got, you have less downtime and so on and so forth? Is this something you calculate? Yes, we've got to do that because this is what our customers are interested in. If they have a new product, the customer expects to have, well, if they have better performance data that costs more, they've got to have a return on investment for that too. That's definitely true. It's difficult to calculate this ahead of time. We saw the tests here. There are possibilities to look ahead and make a forecast as to how good the product will perform in the market. But nevertheless, I still think that we've got to have this interchange and interaction with the final customers, so that together, as I discussed with our customers here at the trade show, we can really establish a technology partnership and enhance it. Because what happens in the marketplace? Well, we separate more and more the different general areas and have more and more specialists now. Now, before I say, okay, I don't want to deal with certain subjects at all, and we get into a situation where the performance isn't achieved, let's say if you're a machine builder and you move into a situation where you're no longer competitive, then that means, basically, it's essential to have joint development so that we're able to support our customers more in certain areas than before. But we could talk about that for a whole day. Well, one thing I think is really interesting is that you're a huge corporation. We shouldn't forget that. We're not just talking about a little shop where you say we're going to make one product for a small niche market, but you're making many, many products for a lot of smaller areas. You've got to do that in your whole huge corporation. Yes, and that's our strategy. We have strategic trade partners. They're in markets. They're locally represented. They're on site, and they can react much better to requirements, in particular in machine shops, than we can. And that's why this type of cooperation is very important. Now, I have a question for you. It's more of a technical one. Let's say you monitor your machines, and then you see, well, you can't recognize it with things with the naked eye, these problems. What about sensors? Do you have solutions there? It'll be constantly monitored, not going to do it proactively, you're going to wait until something happens, or what's done there? Well, there are sensors everywhere. I'm a little bit conservative. My professor in measurement technology said, if you measure a lot, you measure a lot of crap. So you've got to process and understand and react the data. Now in machine shops, in particular for metalworking, legal requirements are that you've got to do manual measurements. In addition to that, there are sensors now that can do certain things, but in my opinion, now I don't want to step on anyone's toes here, but they're not mature enough. They're not at a level where we could say, okay, I will trust this information automation, 100%. Well, then we have to ask the next question. We'll take another one afterward, but we have to ask this one first. Now, when you've gathered some data manually, you've got these partnerships, and now you can set up data models. We're talking about AI here, right? So I've got to ask this question. Do you already use AI so that all of the data that you get from your partners are brought together and say, okay, what combinations might be successful? Yes, we do sometimes. In development, definitely. We take advantage of the pool of experience that these companies have garnered over the last few decades. Some of that is used, yes. And that makes sense. And in certain areas, it really does help us out. I have a technical question. Is an oil-free lubricant better because it doesn't emulsify the slide-away oil? Well, it depends. Of course, you can use it. And if you want to use a fully synthetic product, definitely it'll work. But I'll tell you about two things here. First of all, it's very expensive, comparatively speaking. It's a nice solution, definitely, but the machine has to be designed for that. Let's say sealing material. You want to make sure that there's no leakage there, so you've got to design for that. I've had experience here. Developments are always moving forward. You've got a machine that's 5 years old. It's got normal rubber seals in it, and the customer will say, okay, I want to take the next step, and now I'm going to switch to fully synthetic oil. But the problem is this. We're talking about polarity here of, well, with the seals, like oil and vinegar, so they do interact, but not the way they should. They get hard, they get brittle, they get cracks, and then you've got leakage that you don't want, and then you've got to take the whole machine apart and fix it. You've got downtime, you've got to do maintenance, so you have to really think about whether you want to do that. So in technology terms, in terms of performance, they're very good, definitely, but, well, and they're also stable in terms of the biology, but it really does depend. So I'm very proactive in application technology because there are no simple answers anymore. Everything's much too complex. Thank you. Great. Great final word. Thank you, Thomas Bergmann. Let's give him a big hand. Great presentation. Thank you, Thomas.